Good afternoon, everyone, and welcome to part 3 of the Pedestrian and Bicycle Transportation course. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation in this training. Please note that today's session is the third of a 4-part webinar series, with part 4 tomorrow afternoon. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the course presentation, please use the questions box to send in any questions you might have, and I'll be dispatching those periodically to the instructor. Please note also that the handouts section of your GoToWebinar panel includes PDF copies of the course presentations for reference. With that, we will go ahead and turn things over to our instructor, Ron Eck with the West Virginia LTAP Center. Ron, welcome back for day 3.
Thank you, Mike. Welcome, everyone. Welcome, everybody, back for part 3 of the session. We're a little bit behind schedule, so I may pick up the pace a bit, but please don't let that discourage your questions or comments, or if I went over something too quickly, just put something in the chat box or in the question box, and we'll get to it and address it. I want to make sure everybody gets their concerns and questions responded to during the sessions. Maybe for start, Mike, why don't we do the next polling question?
Sure.
It relates to what we talked about last week in terms of crosswalks.
Yep, so we have launched the first poll question. What materials does your agency use to mark crosswalks? And you can check multiple options here. And we see the responses arriving already. And about 70% have voted so far. We'll provide a little more time. Okay, so let's share the results. So Ron, 68% said paint, 74% said thermoplastic, 23% said epoxy, and 10% said other, and then typed into the questions box, someone typed in brick pavers, brick/stamped concrete, and then someone typed in they've recently changed over to acetone-based paint. Previously, we're using water-based.
Okay, interesting. Well, thank you. Yeah, so it looks like thermoplastic narrowly came out ahead, and then we have paint close behind that. So interesting results. Thank you, everyone, for responding to that. Last time we talked about some pedestrian islands. We talked about crosswalks. I think I shared a unedited version of this same slide with you. Now it's been photoshopped. If you recall, last week or last time, this family was actually just standing in the flush median. Now we've put a grass median, and notice a channelized for pedestrians island here. And this is sometimes called a Z crossing. Notice that as the pedestrians would cross from the right to the left, they then turn to their right and walk for some distance toward the traffic stream they'll be crossing. And so that allows them to judge speeds and distances and gaps to the oncoming traffic stream. And then they turn to their left and cross that direction of traffic at right angles. And so safety should be improved. Notice the island here needs to be detectable so that someone using a cane, a visually impaired blind pedestrian, is able to detect those changes in direction. So today we'll look briefly at signals and then also overpasses and underpasses. In order to install a traffic signal or beacon, there should be a warrant study done. Of course, as the first bullet says, there is a great deal of flexibility in applying the warrants to determine if a signal or beacon is needed at a pedestrian crossing. And I think I mentioned last time, it's important to take into account both the existing as well as the projected demand. And there's an additional warrant for the pedestrian hybrid beacon, the PHE, in Chapter 4F of the MUTCD. And the hybrid beacon can be used at location where the warrants for a signal are not satisfied, or where warrants are satisfied, but the decision is made not to install a signal. And here you see an example, a graphic of the hybrid beacon at a crossing. Notice the marked crosswalk and then the pedestrian refuge island with the detectable warning surfaces, and then crossing the other side of the street. And just briefly, for those of you not familiar with the operation of the pedestrian hybrid beacon, this graphic shows how it works essentially with respect to what the driver sees and what the pedestrian sees. So with this, there is some motorist or driver education aspect as well, because it is kind of a non-conventional signal head with the T-shaped head, and also the fact that its normal condition or normal state is the dark state. Another crossing treatment that we're starting to see more widely used around the country is the rectangular rapid flashing beacon. Maybe used at uncontrolled crossings where a signal or a pedestrian hybrid beacon is not warranted, or maybe cross prohibitive, or just deemed unnecessary. You can supplement the warning signs with the RRFB as you see here. And those rectangular yellow lights flash rapidly when in yellow to warn motorists that a pedestrian is in the crosswalk. Notice the second bullet says use it with caution at crossings with more than 2 lanes without a refuge. And I would note here, I'm not saying this to discourage this, but notice there is a push button on this particular one, kind of active detection, if you will. So if you're using that push button, of course, there needs to be a locator tone for the visually impaired pedestrian. And then I would contend also that there need to be some sort of voice message to explain the situation, because I believe when most visually impaired pedestrians, they go to what's called orientation and mobility school, or O&M training, to learn about the built environment and navigating throughout that environment, learn about things like the detectable warning surfaces, push buttons, and so forth. And I believe they're taught at O&M school that when they hear the locator tone for a push button and they push that button, and then the walk indication comes on, that they are at a standard or conventional red, yellow, green traffic signal controlled intersection. But here, of course, when they might hear the walk indication come on, or they might push the button, but they need to be advised, in my opinion, that this is not a standard red, yellow, green traffic signal. This is simply a warning device. It's not like motorists are facing the red ball, they're facing just flashing yellow. So that's an issue, I think, to be addressed with these with respect to ADA. And here you see a similar graphic, the RRFB and a crossing island, and the signing that would be associated with that. And also notice the advanced yield line here in the foreground and also in the background for the other direction, which I believe was the last thing we talked about in last Thursday's session. Roundabouts, I think, have been a great traffic engineering device. They reduce crashes generally. They certainly reduce crash severity, because what had been T-bone crashes tend to become simply sideswipe crashes. They can be an attractive element or gateway to a neighborhood or community or college campus. But probably one issue with them is that visually impaired pedestrians do have some difficulties or some challenges at roundabouts. And if you'll notice here on the left-hand image, this shows, of course, how pedestrians generally cross at a roundabout. Notice they cross about 1 car length back from the yield line through what's called a splitter island. And it looks like this dimension is such that this would appear to be a refuge island. And notice just one criticism here. It looks like they failed to put in the truncated dome detectable warning surfaces there. But the pedestrian would cross here and actually can cross, of course, one direction at a time through the splitter island. I think we've talked about these. But as it says, one of the issues is the visually impaired. And up here on the top left, you see a different perspective, more from the center island of the pedestrian crossing to the splitter island. And again, it looks like the detectable warning surfaces are missing, or if they are there, they don't have sufficient contrast. But as you may be aware, it appears that in the final form of PROAG, some form of signalization will be required at new multi-lane roundabout pedestrian crossings. And that's due to the multiple threat crash problem that we talked about near the end of class last time. So let's look at the lower right image to illustrate that. And so this requirement would be at multi-lane roundabouts, not single lane roundabouts. We can tell, I think, from the service animal here, or the guide dog, that this woman is visually impaired or blind. And so she is relying basically on hearing or tones from, say, an APS, an accessible pedestrian signal, to help her navigate the intersection. And here there are no tones, if you will, no APS, so she has to rely on traffic sounds. And would you agree, she can hear this white car to her left. The challenge she faces, though, is she can't tell if that car is going to go around the circle, like the yellow pickup truck there in the upper center, or is that car, as it appears, it's going to leave the roundabout and enter the same roadway that she wishes to cross. So that's one of the challenges. Another challenge would be in a safety issue, and it's not in this image, but I'll ask you to imagine it. Imagine a large pickup truck is traveling in the right lane here behind the shrubbery and landscaping. And let's say that driver sees the guide dog and yields to the pedestrian. In so doing, with his vehicle, his or her vehicle stopped here, now the driver of this vehicle can't see the pedestrian because his or her view is screened by the pickup truck in the right lane here. And it also complicates significantly her ability to cross the street, because now she really can't plainly hear this vehicle anymore, especially if the engine noise from the pickup might be loud. It kind of confounds the noise, the sounds that she's listening to for other vehicles. So it really creates some issues. So that's why PROAG is requiring that some form of signalization be installed in those instances at multi-lane roundabouts. And that signalization does not have to be standard, red, yellow, green signal head. It might possibly be the pedestrian hybrid beacon, or perhaps even the rectangular rapid flashing beacon. What about bikes and roundabouts? Here, there's really two different ways a bicyclist could negotiate a roundabout. They could negotiate it just like a motor vehicle, meaning with traffic in the roadway, and go through the roundabout that way. Some of the, we talked about the first day of class, the different classes or categories of bicyclists. Some of the less comfortable, inexperienced novice bicyclists may not be comfortable doing that. So another way to navigate the roundabout, if you're a bicyclist, is to access the sidewalk and then negotiate the roundabout like a pedestrian. And I showed you this image before, and I'm not circling the pedestrian here. Unfortunately, the pedestrian is blocking what I'd like you to see, but you can't see it behind the pedestrian here. But this little section of concrete surface, and there's a ramp here. Notice the bike lane. This is for bicyclists to, if they want to, they can exit the roadway and enter this concrete surface to access the sidewalk here. So either of those two ways could be used. Overpasses and underpasses, a great way to reduce pedestrian vehicular conflicts because we have grade separation. The pedestrians are at one level, either over or under the roadway, and the motor vehicle traffic is at another level. You see an underpass there on the right. Sometimes those present some challenges and issues for designers and for pedestrians. They're often dark and damp and may create some security issues. But I think if they're properly done, like this one on the University of Colorado Boulder campus, I think you'll find that they are and can be used effectively and safely. One of the challenges, though, with these grade separated structures is, if you recall the first day of class, I talked about we humans are energy minimization creatures. We don't like to change grade or go out of our way for any significant distance. So as you see on the left photo here, unless there's some barriers or obstacles or something to really discourage or prevent pedestrians from crossing at grade, they are going to continue to do so, in spite of the fact that this is a, appears to be a nice, properly designed pedestrian access route accessible facility. Because of the ramps, it does involve some extra travel distance and also obviously some change in elevation. So this photo on the right this is probably, I don't know, 1960s or 1970 era ramp at an overpass, but I like it because notice, kind of tucked out of view here, there is a stair system, flights of stairs that go from the sidewalk up to the overpass level. The reason I like it is because able-bodied pedestrians who maybe don't want to walk the full distance of that ramp can utilize the stairs, and maybe that would, several of them, some of them might be encouraged or enticed to do that rather than to try to cross at grade. So I realize stairs are not an accessible walking facility, but I don't think we should forget about stairs. I still think they have a place in our built environment. In fact, I was reading in the last year in some public health journal that the physician who authored the article mentioned that people with certain types of cardiopulmonary conditions, that he recommended stairs over an extensive ramp system like you see there. And I may, a couple more times today, I may talk about stairs as well as ramps. But of course, remember, stairs are not accessible. We do have to have an accessible route. And then this one I titled, What Were They Thinking? This is in North Carolina. I won't mention the community, but just puzzles me. This brick building in the background is one of the high schools in the city, obviously a fairly large high school. Where I took the photograph is a parking lot for one of the larger parks in this particular city. I think it had a swimming pool, playground, ball fields, greens, a lot of green space. So it was a very popular park. And as you might expect, with the school here and the park here, and what you can't see is I think it's a 4-lane arterial roadway here, not limited access, but a relatively high speed, high volume arterial roadway here. And so a lot of students, of course, would move to and from between the park and the high school. So the community put in this overpass structure. And the story I heard from some of the maintenance folks that were in my class is that the students would cut holes in the fence here and continue to cross at grade. I'm sure many of you have probably seen that as well. And that kept happening for a few years. And then rather than maybe try to think of what would be a creative solution to deal with that, I think you can see what the community did was simply remove that section of chain link fence and then also added a section of sidewalk. I think you can see that's a newer piece of concrete there going right out to the arterial street. And this concerns me for a couple reasons. One, of course, is safety. now pedestrians are being led into an at-grade crossing, kind of middle of the block. But also, I would think that would be a liability, a tort liability exposure for this particular community. So I'm not sure what their thought process was, whoever did that. Bridges and bridge design. We see a number of examples here. I think on the outside here on the left and right, these are multi-use shared use paths where there is no motor vehicle traffic. And you can see bridges allow those paths to continue over water bodies or railroads or roadways, whatever it might be. So they're a key part of that trail network to keep it connected. But then in the center, you see a couple examples here. It looks like a new major bridge crossing over a significantly sized river here. And I'm hopeful that there will be provisions for pedestrians and bicyclists on that particular crossing. And then the top one here, I believe this is Portland, Oregon. I kind of like this. This bridge is probably maybe 100 years or so old, but it's really, in spite of its age, it's been adapted to serve really all users. Down below here, within these trusses, is a mainline railroad crossing the river. Up top here is the roadway for motor vehicles, but also in the center of that, in the median of that roadway, is a line from Portland's light rail system. So it carries transit as well. And notice kind of a retrofit, this was after the fact, but notice that there is now a nice pedestrian bicycle crossing attached to that bridge structure as well. And so I really like that older bridge, but yet now in modern times, it literally serves all users. So I mentioned bridges are important and they should accommodate both pedestrians and bikes, because without that sort of ped and bike access, there may be really lengthy detours like that photo I showed you in the bottom center of the previous slide. It could be many miles before there's another crossing of that major river that you saw there. And so we need to accommodate both the bridge itself, the overcrossing, but then also if there's pedestrian or bike connections in the undercrossing. So this looks like maybe a canal here or something. And there's probably some sort of shared use path along the canal here for pedestrian bicycle travel. Notice on the bridge, motor vehicle bridge, they have wide sidewalks on both sides. But also notice the connection here from the overcrossing bridge to the lower level. And there's both this would be an accessible route, also for bicyclists. But then, as I mentioned, I think it's a good idea to have some stairs there to provide a shorter distance, more straight line path for the able-bodied pedestrians. And here's sort of a real world example of that. Maybe some of you have been there. That seems like just yesterday, but I've probably been 10 years or so since I took this photo. But this is near the Hoover Dam in Nevada, or the Nevada-Arizona area. And as you may be aware, I forget when it was, but in the last couple of decades, because of security concerns, because old US 93 actually traversed across the top of the dam. And so you had trucks and buses and automobiles traveling over the dam. And so there was obviously security concerns. So a new bridge was built that actually overlooks the dam. It's a beautiful panoramic view of the Hoover Dam. And so the bridge is kind of a tourist attraction in itself, and it has its own visitor center. And on the left here, you see the parking lot for to access the bridge and the overlook of Hoover Dam. But the point I wanted to make, and you can see a lot of earth moving and rock moving was done here. The bridge is up here, the sidewalk on the bridge, out of the view of the photograph. But notice they have an extensive ramp system, switchback ramps, to provide an ADA accessible route to the bridge up here. But here on the left is are numerous flights of stairs, so the able-bodied can take a shorter path. And notice I think this was a Sunday morning I was there, notice that most of the folks there were able-bodied and took the stairs. You see a few people on the ramp, but I did both, and it certainly was really a quicker path if you're able-bodied to take the stairs rather than the switchback ramps. So again, I would just mention we shouldn't forget about stairs when we're designing the built environment, as long as we have an accessible route as well. I think I've talked about these. Make sure your grades meet the accessibility standards. And where bikes are permitted on the connection, the best design would not require them to have to dismount. With stairs, as many of you may be aware, there's a possibility to use what are called bike channels to accommodate bikes on a stairs, kind of a flat ramp parallel to the stairs on which you can roll the bicycle. One of the key issues, though, is make sure that the design that you use doesn't interfere with the access to the handrails for folks that need the handrail. And I think here's a couple examples. Here's kind of a schematic on the left, a conceptual drawing of what this would look like. And then here on the right, you see an actual one. This one looks like it's concrete. And I think you can see how you do have to take care, because the separation from the stairs here to the railing, I'm not sure that would comply with ADA criteria. I'm not sure a small stature, say older person, would be able to reach the railing from the stairs here. I guess they'd have to travel on the other side of the stairs, and potentially this, lips here and so forth could be a tripping hazard for pedestrians, for able-bodied pedestrians. What about the width of the travel way? Especially, say we're talking about bridges. Remember, I think we talked about the first day, there is a shy distance for pedestrians and bicyclists. As humans, we don't travel directly against a wall or a fence or a railing or something. So we need to factor that in and recognize that there's kind of a functional width and then there's an actual width. And if we have railings on both sides, the functional width will be narrower than the actual width. Desirable clear width for a sidewalk on a bridge is 8 feet. Minimum width for one-way bike travel, I think we talked about that on day one, is 4 feet. Bridge railings help give a feeling of security and safety to both bikes and pedestrians. Recognize that bicyclists have a higher center of gravity than a pedestrian, and so railings where you have bikes, say on a structure or even along a path or something, if you have a safety railing, the railing should be a minimum of 42 inches high. And then if you have bridges that accommodate both vehicular and pedestrian bicycle travel, there should be a crash-worthy railing between the vehicular traffic stream and the pedestrian bike facility. And here's just an example, I think a neat example. This is from the Hudson River Valley, Poughkeepsie to Highlands, New York. This bridge, back in its heyday, the heyday of the railroads, was a double track. You can see a large span over the Hudson Valley and the Hudson River at this point. Has now been converted, as you can see here, into a nice multi-use or shared use path facility. You can see that looks like concrete surface, nice railings on both sides, and has become quite attractive. They have a festival every year, and actually has become not only a good connection, but really I think this is part of kind of the economic development component, if you will, of this whole part of the Hudson River Valley. So it's an example of what the potential can be for facilities like this. Tunnels and underpasses need to be designed for the tallest likely user, which may vary. In some cases, I may have showed you some last time, it may just be someone on a bicycle. this looks like it's over-designed for the person on the bike, but it may be that maintenance vehicles pass through this structure, this undercrossing of a railroad, or there may be folks on horseback, equestrian. So you do need to think about what is your tallest likely user and design the tunnel clearance for that. I think I mentioned the underpasses. If you're going to do it, this is probably a good way to do it. Notice it's reasonably well lit. There is lighting at night. It looks like there's some artwork on the walls to try to make it attractive and have good visibility throughout. So any questions on any of that material? This is from last time.
Yes.
You can put those in the chat box. Mike, we have some questions.
Yes, Ron, going back to the start of this afternoon's slides, we have a comment and question from Matthew. He says he has read that some jurisdictions are performing the signal warrant study after installing the signals and pedestrian signals. In other words, build it and they will cross. So they test to see if enough pedestrians use a crossing after it is safe to determine the warrant. Your thoughts?
Yeah. Yeah, I mean, I think the thought is good. I don't know about I'd have to think about, from a sort of a tort exposure standpoint, but I think the idea of recognizing ahead of time that there's probably a lot or significant demand out there from folks that are not presently crossing because it may be so difficult for them or just unattractive since there's no signal to create a gap in traffic. So if there be some way to sort of estimate that or predict that, that would be a good thing. I'll have to give some more thought to the idea of, sort of meeting the warrants after the fact. But good question though.
All right, thanks, Ron. We have a question from Cynthia. She says she has not seen bike channels before. Is this a regional thing? Where are these currently in use?
Oh, good question. I think they might be in use around the country. I know I'm not sure where they started in the US, but I believe in, for example, New England, there are some applications. Because I'm thinking, like some of you, I'm a member of APBP, and I remember I'm speaking now, this is probably 10 or 15 years ago, but I remember when they had their old version of their listserv or their community or whatever they call it now. Oh, for a couple years, there was regular every week, it seemed to be discussion on the listserv about these bike channels. And I recall a number of examples, photographs and things that people were including as part of their responses came from New England. But I think I've seen some in California and other places as well. At one of the classes I did in person here in the East, I can't think whether it was West Virginia or Virginia or Maryland, but someone inquired about that as well, or where you could get some of the products. And I believe there is a metal product, but I believe the issue that the person was raising concern about or a problem with was that I'm not sure there's a US manufacturer of the metal channels. If anybody here on the session can correct me or provide updated information, that would be great. But I think at that time, which was a couple or 3 years ago, the only manufacturer of the metal channels was it might have been European, and I think his agency was having some issues, being able to acquire something from an international producer.
So Ron, with regard to the initial question about bike channels, we have several comments people have typed in. Larry says, Dayton, Ohio, invented by the Miami Conservancy District. Okay. Matthew says, bike channels are common in Dayton, Ohio. Brad says, there is a bike channel in Dayton/Oakwood at Patterson Boulevard. They actually embedded a U-channel post typically used for signs and placed it in a concrete curb along the stairway, is what he said.
Oh, nice idea. I like that. Yeah, thank you all for contributing. So Dayton appears to be a real hotspot where people can see some examples.
All right, so those are the questions for now, Ron.
Okay, thank you, Mike, and thank you everyone for good questions and comments. Well, let's move on then to the day 3 portion. And today we'll talk about some peds and bikes at interchanges, a little bit about bus stops, something about maintaining roads and streets for all users, and then sidewalk work zones. But before we get to that, I did want to say a few words about what I guess I call road reconfiguration. I used to say road diet, and people would say that they thought diet had a bad connotation. But road diet or road reconfiguration basically means revising the lane use or widths so that you have, in the end, one travel lane per direction, probably of minimum width, to try to reduce the cross section, and then use that, the cross section that's becomes available then because of the narrow roadway, to do things like a dedicated bike facility, left turn lanes, on-street parking, raised medians, ped refuge islands, sidewalks or wider sidewalks, so to truly make it sort of a complete street or designing for all users. And just basically, here's kind of the schematic. This would be the before situation on the left. Notice 2 lanes per direction, 2 lanes undivided, just the double yellow center line. And then this is one possible reconfiguration after the fact. It doesn't have to be the only one, but notice there's now 1 lane per direction. There's a 2-way left turn lane in the center, and this isn't designated out here, this is sort of the shoulder, but this could be a bike lane. It could also be parallel on-street parking, again, depending on your particular context, or both even. I think I'll show you an example of both, where you have parallel on-street parking as well as bicycle facility. This works really for nearly all roadway functional classes. It can be used in urban, suburban, rural settings. Probably most appropriate for the common urban speed limits. And you can apply it at or near intersections or on road segments. It also works along bus routes. The idea is with narrower lanes and fewer lanes, you have reductions in vehicular speed. So any crashes that occur should be less severe, probably also fewer crashes. And the reduced motor vehicle cross section makes crossing the roadway easier for pedestrians. You do have to consider, though, the transition from the adjacent roadway sections and through intersections. And also keep in mind that since the number of available lanes is reduced, the design impacts demand that can be accommodated, meaning the typical threshold is about 1,000 vehicles per direction during the peak hour. And probably on higher volume roads than that, the road diet is probably not going to be a viable solution. We have here in Morgantown, one of our main sort of roadways into the heart of the campus, if you will, is a 5-lane arterial. And there is has been a group in the community for many years that's been pushing to have a road diet there, to have it 2 lanes in each direction and then make the median an attractively landscaped sort of gateway into the community, if you will. The only problem is that the ADT on the road right now is about 35,000 vehicles per day, which certainly exceeds the 1,000 vehicles per direction during the peak hour. And so that's a case where that arterial, really a road diet is not the way to address the issues with that arterial, simply because the motor vehicle traffic volumes are so high. I think we've talked about this. And here's a couple examples. This is a Suburban, I believe this is in Maryland. The before situation is here on the left. You can see just what I showed you, 4-lane undivided roadway. And then on the right, we see 1 lane in each direction, left turn lane here, a two-way left turn lane, and then a bike lane along the curb. And this looks like one of those transition situations where you're transitioning from the wider cross section down to one lane in each direction. And then here is an urban example from Seattle. It's not the same section of road, unfortunately, but it is the same corridor, just not the same block or of the street. But notice before, again, it's 4-lane, undivided, and then after it's 1 lane in each direction, a 2-way left turn lane. Here we have parallel on-street parking and also the bike lane here. That's the reconfigured roadway. Another issue, depending on your community and the design of the roads and freeways and things, is what about pedestrians and bicycles at interchanges? And here what we're seeing is, this says entrance ramp, but I guess they are entering this roadway, of course, but it could also be an exit ramp from a, say, a freeway or interstate onto a local road or street. And so in that case, traffic would be coming from the higher speed facility to the lower speed facility. But notice, given the angle of merge here, a lot of pavement area, open pavement area, not very good for pedestrians or cyclists. So a good way of handling that, notice here, is to try to cross that ramp at close to right angles, both for pedestrians and bicycles, to minimize the crossing distance. And you may want to do some other things as well, as noted here. So try to minimize the conflict points between pedestrians, bikes, and vehicles. If there's things you can do to design the ramp geometry-wise to slow vehicle speeds until they're past the crosswalk, because of course one of the issues in this situation, if this is a, say, the exit ramp from an interstate to a local, to a city street, if drivers have been on the interstate for many, many miles, they're conditioned to that 70 mile per hour or so speed, and they're still going to be at significant speed on the ramp here. So if there's things you can do geometry wise through narrowing or whatever to try to reduce those vehicular speeds, that would be good. Make sure the crosswalk is at a location with the best visibility, and those crosswalks should be as short as possible. Make sure design or define a weaving zone where bicyclists can decide when to merge across vehicle lanes. Make sure the off and on ramps are at right angles to the arterial roadway to encourage slower speeds. This might be a good place to use color treatments for bike lanes. We'll talk about a little bit about that tomorrow. Make sure your pavement markings are in good condition, high visibility type, and have directional curb ramps for your crosswalks. And we talked last time about the advanced limit lines for multi-lane crosswalks. That's particularly important here. Bus stops, really a critical connection point between modes, pedestrians, bicyclists, transit riders, all kind of share the need to access those particular stops or points. So they should be comfortable, safe, convenient, and I would say designed for the local context in your community or in your neighborhood. There needs to be an accessible route connecting the stop to the sidewalk system. Should be located where there's existing or future demand. Think destinations like office buildings, schools, medical centers, shopping areas, apartment complexes, anything that generates pedestrian or bicycle demand. And then at intersections or mid-block, consider if a marked crosswalk or additional crossing treatments are necessary. Like, is the bus stop or transit stop generating, sort of say, mid-block crossings, as when folks leave transit, are they headed to some destination, say in the middle of the block on the other side of the street, that maybe warrants some sort of, maybe a marked crosswalk with some additional crossing treatments or enhancements. What's wrong with this picture? Clearly that's not an accessible bus stop. Notice the sidewalk stops here, probably, what's that, 20 feet or so from the bus stop. Clearly this should be accessible, or else the bus stop should be relocated. Clear zones, because especially if you have a shelter, that bus stop becomes a fixed object hazard, if you will, that shelter. And so we do need to consider the what AASHTO's roadside design guide says about clear zones. Because as you see here, they are fixed object hazards that can be struck by motor vehicles. And so you may want to think about treatments to help keep vehicles on the roadway by using good pavement markings, maybe edgeline rumble strips, delineation, or something like that, when you have, as it says here, a reduced clear zone width. Considering clear zones, put the stop as close to the travel way as you can. At intersections, you can put the stops far side or near side. Probably transit agencies generally prefer far side stops where you have heavy traffic flows, where there's sight distance problems or where buses turn left. But near side may be appropriate where the traffic flow is lower or where transit riders can more easily transfer without crossing the street. Should have an 8-foot by 5-foot minimum boarding and a lighting area that's free of obstructions. That's required for accessibility. And there should be at least a 10-foot wide boarding and a lighting area long enough to accommodate the bus stop elements, including the boarding and a lighting area, the shelter, and so forth. In rural areas, vertical curbs should not be used at the bus stops because, of course, that's a barrier to the disabled. So here you see an urban bus stop design with the shelter. Notice basically the clear zone in this case includes looks like a narrow buffer strip or tree lawn, and then the width of the sidewalk essentially. We do need to consider accessibility. What's wrong with this picture? Well, of course, the driver has lowered the ramp here, the bus driver, for someone in a wheelchair to exit the bus. But notice once they get to the base of the ramp, there's not sufficient sidewalk width here for them to turn the wheelchair. And so this is not an accessible bus stop. Fortunately, in this particular example, which is in Virginia, if you go to the lower left of the photo, about 80 feet or so, the sidewalk widened to about 12 feet wide. And so what the agency did was simply move the bus stop about 80 feet to the left in the case of this photo. And there they were able to provide an accessible stop. So these are the elements of the bus stop. I think we've seen a number of these in the images. The shelter, advertising, like it says here, may help offset some costs for the agency, but can block sight lines. And think about additional amenities, benches or lighting, the routing and scheduling information, trash receptacles, bike parking, depending on what works, what your space allows. But also throughout all of that, when you're placing those amenities, keep accessibility in mind. Make sure the bike rack or the trash receptacles don't interfere with the accessible routes. Maintaining roads and streets for all users. Here we're looking at maintaining sidewalks and streets for pedestrian and bicycle users. Some things to keep in mind, some of the challenges. that we face in keeping facilities safe and accessible. Of course, federal funding is not available for maintenance, and local agencies typically are constrained in their resources for monitoring, inspecting, maintaining pedestrian facilities. And in many cases, the property owners may be required to maintain the sidewalks in terms of their structural condition, in terms of snow and ice removal, and so forth. And we also need to keep in mind that sort of overarching all of this is not only are there Americans with Disabilities Act issues or challenges, but also tort liability consequences, meaning if there's a heaved up sidewalk slab, say on one of the sidewalks along one of your streets, that could be an ADA issue if that sidewalk slab is heaved up enough such that, say, someone in a wheelchair can't use that section of sidewalk because that heaved up slab is a barrier. That could subject the agency to an ADA claim, a civil rights lawsuit. But at the same time, that heaved up sidewalk slab, if an able-bodied pedestrian trips and falls on that and fractures a hip or fractures a collarbone, they could file a tort claim against the agency. So it could be kind of a double whammy where the agency could have legal exposure in two different areas, in civil rights law with ADA and in tort liability law if someone is injured. And this just shows just a few of the challenges. Different property owners, the number of properties along this sidewalk, each of them may be responsible for maintenance. And so just on a snowy day, notice it looks like this property owner did clear the sidewalk in front of his or her property, but it looks like maybe the neighbors here have not cleared their sidewalk. And then it shows kind of another issue too. Notice because there's no furniture or buffer zone, may well be that when the road agency plows the road, that not only does the property owner have to remove the snow that fell on the sidewalk, but may have to remove the accumulation of slush or the windrow of snow that the plow deposited there as well. And as I've alluded to, what may seem like kind of minor maintenance issues, like a heaved up sidewalk slab, can actually discourage or prevent walking and be a barrier to people with disabilities, but can also be a tripping hazard that can cause falls and injuries. And the maintenance of roads or streets should cover, all of these things: the sidewalk, the curb ramps, pavement markings related to pedestrians, crosswalk markings, pedestrian signals, and the hardware that is associated with those signals. So public agency practices need to ensure that the day-to-day operations keep those paths of travel open and usable for pedestrians, including those with disabilities, throughout the year. And so, for example, in Ohio or West Virginia, I realize we have people from all over the country, but for example, in this part of the country, that includes snow and ice removal and treatment, debris removal, other types of maintenance activities, so that there should really only be isolated or temporary interruptions in movement or in accessibility. And this is actually, as I mentioned, part of ADA, and you can see it's Title II of ADA, and there's the Code of Federal Regulations citation. But state and local governments must maintain the accessible features of facilities in operable working condition. And they go on to say public entities must maintain equipment and features of facilities that are required to provide ready access to individuals with disabilities. So we can't just build something and forget about it. We do have to maintain it. If we can, probably a good idea to identify funding for maintenance before a project is implemented, and recognize that we're going to have to probably have routine or preventive sort of maintenance, like depending where you are in the country, snow removal, ice treatment in the wintertime. tree trimming, vegetation trimming, those kinds of things to prevent vegetation from overgrowing the sidewalk or blocking sight lines. But then also recognize that periodically there's going to be other maintenance, such as repairing cracked sidewalks. Crosswalks have to be restriped. If you have brick or paver block walking surfaces, those may need to be reset because they've heaved or buckled or settled over time. So we need, our budget should include provision for that as well. Some common sidewalk maintenance issues: surface defects of various types, concrete spalling, scaling of concrete, pop outs, cracking of the pavement. Now this looks like an old section of sidewalk. It's pretty much really non-traversable by someone in a wheelchair or probably someone with a walker. Also presents a lot of potential exposure where someone might trip and fall. An able-bodied person might trip and fall. Uplift or settlement of slabs. I mentioned tree roots, heaving slabs. This one here on the left looks like maybe it's sort of utility related perhaps, but notice the sidewalk slab is heaved up, creating certainly a safety issue. You could address those, at least temporarily, by maybe putting in a wedge of concrete here. ADA would require that have, if it's between a 1/4 and a 1/2 inch, that it be beveled at a slope of 50% or 2 to 1. Another approach is, of course, like you see here on the right, grind the higher elevation down to bevel it or ramp it at that slope that I mentioned. I talked about the displacement of pavers. Here we see an example, what can happen to pavers over time. And again, this is certainly a tripping hazard here. I guess we could argue there's still probably an accessible route around it, so it may not be an ADA barrier or obstacle at this point. But if it's allowed to continue to kind of deteriorate, or the movement allowed to continue, eventually that sidewalk may, or that walkway may not be accessible either. A settlement of surfaces. Not sure this is necessarily an ADA violation, but notice the surface has settled. Certainly if any pedestrian passing through there, it's kind of just an annoyance to have to deal with that water. But in your colder climates, in northern climates, that water can freeze during the winter time. Then you have maybe a slippery sidewalk that could lead to a slip and fall and a tort claim exposure. Vertical discontinuities at utilities, that's quite common. Here we see a sidewalk that's kind of cracked and settled around a utility cover, leaving some edges here that could represent a tripping hazard. Here it looks like a utility cover has settled with respect to the sidewalk, and so now we have an elevation difference that creates a tripping hazard. And then here we have the utility cover with, I guess, the remote meter reading that may be a potential impediment to pedestrians. Depending where you are in the country, maybe water flowing across the sidewalk. In this case, it looks like the water sometimes may be enough to carry sediment and mud out onto the sidewalk, so then you have a slippery surface. Depending where this is in the wintertime, if that water continues to flow, you may have an isolated icing condition on the walkway, which is also a slip and fall hazard. Loose material on the surface. This is in snow country. What you see on the sidewalk here is anti-skid or abrasive material that the road agency put on the roadway in the wintertime, but some of that ends up on the sidewalk, and when it's dry and kind of loose like that, that can present a tripping hazard, kind of a slip and fall hazard as well, I should say, not tripping, but slip and fall hazard for pedestrians. And then even some of our, accessibility features, they need to be maintained as well. Notice here on the left, the detectable warning surface has started to weather and age, I guess, and so it's curling up, and that's could prevent or present a tripping hazard for pedestrians. Here on the right, we see some of the cast iron detectable warning surfaces, which are popular in snow country because they are pretty durable. But notice in this case, they're so durable that they're outlasting the concrete around it, which is deteriorating and now creating a potential tripping hazard, but also maybe something that, depending on its size, could catch the small front wheels of a wheelchair and cause the wheelchair to get stuck there, perhaps. So you have an accessibility issue as well. Curb ramps, we need to be sure that they're maintained. They should align with the pedestrian crossings. And keep in mind that the use of the diagonal curb ramp, the single diagonal curb ramp, should be a last resort. We should try to use the parallel or the perpendicular or the blended transition sidewalk to street transitions rather than the diagonal ramps. Also keep in mind each curb ramp needs a level turning space, 4x4 or 5x5, depending on your conditions at the top of the ramp for the wheelchair to turn. And then of course the detectable warning surfaces at the base of the ramp, which is a warning mechanism to let pedestrians, visually impaired pedestrians, know that they're entering or leaving the roadway. Crosswalk markings. Here are the couple examples maybe of what not to do. Notice here we do have curb ramps, do have detectable warnings. Really there should be, since it looks like the curb is missing all the way around here, there really should be detectable warnings all the way around here, or else take this pie-shaped section and maybe put a curb here, full height curb. But as it stands right now, a blind pedestrian with a cane could accidentally walk into the street in this fashion. But be that as it may, the point I wanted to make is notice the marked crosswalks here. And marking these crosswalks would be an engineering decision, right? The MUTCD does not require a marked crosswalk here. These are legal crosswalks, whether they're marked or not. But I would argue once you make the decision to mark them, we do need to then make sure that we renew or maintain them, because a low vision pedestrian may depend on that color contrast between the white marking and the darker roadway surface to help them navigate across the street. And if that marking is worn or obliterated as it is here, they lose that guidance information. And then here, I'm not sure how to explain this. Sadly, I see a number of these around the country. But the problem here is notice the crosswalk changes direction in the middle of the street. And that's an ADA violation because it does not allow the blind pedestrian information to know that the crosswalk has changed direction. A blind pedestrian with their cane cannot detect this paint or even thermoplastic. And so once they get sort of lined up with the crosswalk by listening to traffic sounds, they're not aware that it's changed direction. And so they probably will walk more or less straight ahead. So a crosswalk should never change direction in the middle of the roadway. Seasonal maintenance, kind of mentioned that as well. This time of year in the northern tier of the country, snow and ice, especially in the last week or two, has been a big issue. Some parts of the country, including maybe here, West Virginia and Ohio, further south, vegetation growth may overgrow a sidewalk or block sight lines, debris accumulation, those sorts of issues. So Mike, how about, can we do the next poll question?
Yes, yes. So
we're
here
talking about seasonality.
Yeah, we have launched the next poll question. Does your agency have an ordinance or specify a time frame for removal of snow and ice from sidewalks? And we see responses arriving already.
Good. And I realize we may have colleagues joining us who may be fortunately from parts of the country where you don't have to worry about that at this time of year. So just check we have no snow or ice, if that's the case.
So about 70% have voted so far. We'll provide some more time here. Okay, very good. So Ron, the results are 47% said yes, 49% said no, and 4% said they have no snow or ice.
Okay, very good. That's a lot closer than I thought it would be, almost like 50-50. Okay, interesting. Good, thank you. And then another thing to consider is, and this is from an ADA standpoint, ProEx standpoint, is the clear width requirement. ADA, may recall, requires a minimum 4-foot clear unobstructed width. Some agencies have adopted 5 feet, but that needs to be kept clear of permanent and temporary kind of obstruction. So notice that this is a small town in West Virginia, and I don't mean to discourage, there's such advertising here. That's part of I think a vibrant, attractive community. We certainly want to promote local businesses, but I'm not sure that with this sign in place here that there's 4 feet clear unobstructed width. And plus this sign looks like a protruding object. A blind pedestrian kind of lined up with the sign can't detect that, the large pizza panel here, until they run into it. So having a detectable sign and maybe moving it toward the street, or at least making sure there's a 4 or 5 foot clear unobstructed width here. And then on the right-hand side, this is another, I guess, sort of a good problem to have, but it does create some challenges. This is Charleston, West Virginia. You see on the right, this is a popular outdoor dining facility, outdoor and indoor, but they have outdoor dining. And I was with the city engineer when we measured. It's actually 4 feet from the base of the light pole there to this railing. But the restaurateur is doing so well that he was wanting additional width of the sidewalk. But the city had to say, no, we have to maintain that 4 foot minimum clear width to comply with ADA. So my point is, be sure, I realize there might be pressure or demand from property owners for kind of more sidewalk space, but we do need to make sure we're ADA compliant. I guess the good news in this image here is with COVID, the city has actually closed this street to motor vehicle traffic, and this restaurant has actually built some covered dining out in the street. It's kind of a cooperative effort between the city and the restaurants on that street. So it's kind of creative repurposing of the street, if you will. And then vendors are nice. They're part of an active land or streetscape as well, but they shouldn't be located here where this one blocks the entire sidewalk width. We should make sure that we have some sort of, I think, some sort of inspection program and maintenance criteria for sidewalks to look for things like the displacement of slabs or changes in cross slope or grade or vertical clearances to obstructions, and especially protruding objects like trees that may grow over the sidewalk and of course grow each year, or signs that may protrude over the sidewalk, or a property owner hangs a commercial property owner hangs a drop box or something on a building that creates a protruding object. We need to be on the lookout for those sorts of things. And in terms of bicyclists, recognize that, of course, roadways and surfaces, even trail surfaces, are subject to deterioration, debris accumulation. So we may need to have a maintenance program or sweeping program for that, because as we saw, I believe the first day, because of the small contact area between the bike tire and the surface, poorly maintained areas can pretty quickly become unsafe or even unusable by bicyclists. Other things to be inspected, signals, if you have pedestrian signals, they need to be, and push buttons need to be inspected to make sure they're responsive and working. And signage, of course, deteriorates. Notice this sign has sort of a buildup of crud on it, I guess you'd say. And even though that may not need to meet sign retroreflectivity requirements, I would argue that's kind of pretty degraded there, that it really doesn't get the attention or command the respect of path users. So probably should be cleaned or replaced. Could do a number of different types of inspections, community-wide inspection, zone inspection, or even a spot inspection of a particular site, or they could be an inspection done following a complaint or an injury, or there could be some reporting mechanism for the public, and then we would inspect it after that concern or complaint came in. Alterations. There's questions come up, especially with regard to ADA and PROAG. What is maintenance and what is alterations to the built environment? And the reason that's important, as you see in the first bullet there, is typically maintenance activities do not require us to upgrade the accessibility features, for example, curb ramps. But if we do what are called alterations to a facility, then that may require us to upgrade the accessibility features, for example, curb ramps. And also keep in mind, when facilities are altered, the expectation is that they be made accessible to the extent practicable within the scope of the project. And as many of you may be aware, one of the court decisions back in 1993 that affects this area was the Kinney versus Jerusalem case in Philadelphia, where the court said that when an agency, whether it's state or local, when an agency resurfaces its street, that is considered an alteration. And so as part of that project, the curb ramps need to be brought up to current criteria. And when that decision was first made in 1993, for probably about 20 years after that, it created a lot of kind of differences of opinion or uncertainty in terms of what is resurfacing the street. To a judge or to a lawyer, that probably sounded pretty simple, but as those of us in public works know, there's many, many ways to resurface a street. And so in 2013, the Department of Justice and the Federal Highway Administration came out with some technical guidance on what is an alteration and what is maintenance. And this is that particular image or slide or guidance, if you will. So notice there's a heavy dashed line through the middle here of this slide. Everything above that line is considered maintenance. So if you do that to your road or street, you don't have to touch the curb ramps. So if you, let's say, seal cracks or patch potholes, those are maintenance operations. You don't have to upgrade the curb ramps. Or plowing snow or painting lines and painting symbols and words and things on your streets, those are maintenance. But if what you do to your road or street falls below this line, then it's considered an alteration. And as part of that project, you do have to upgrade the curb ramp. So notice adding a layer of asphalt, regardless of how thin or thick it is, if you add a new layer of asphalt, that's an alteration. Or if you mill and fill, meaning if you mill off 2 inches of existing pavement and then put down 2 inches of new hot mix asphalt, you haven't changed the elevation of the roadway or anything, but that's considered an alteration. And I should note too, and this is one of the many gray areas in PROAG, but if an agency would do multiple maintenance operations, that may rise to the level of an alteration. Just as an example, I mentioned in Morgantown we have this 5-lane arterial. A couple of years ago, our state DOT, it's a concrete surface, probably about 20 or 30 years old, and the surface was in bad shape. The concrete was spalling, the joints were in bad shape. So a couple or 3 years ago, our DOT came in and it pretty much took all summer for the project. They worked at night because of the traffic volumes, but they sort of patched the surface, the concrete surface. They repaired the joints, and then at the end of the project, for ride quality reasons, they did diamond grinding. They diamond grinded the surface for ride quality. And I'm not sure who in the DOT made that decision, but I agree with them. They decided that doing those 3 operations, diamond grinding, joint repairs, and patching the concrete, rose to the level of an alteration. So as part of that project, they also upgraded all the curb ramps at the corners along that arterial. So if there are any questions or comments on that, I'd be glad to entertain those. Just enter it in the question box. And Mike, do we have any questions up to this point?
Ron, not at the moment.
Okay, that's fine. Maintenance and operation of bikeways. I mentioned that bike facilities, whether it's the road or a trail or path or something, they deteriorate, debris can accumulate, and they have safety issues. One maintenance operation we could do for bicyclists would be sweeping, regularly sweeping the roadway to get rid of some of that debris in the, especially in curbed sections of roadway. Especially also maybe the presence of loose gravel on the roadway, shoulders. Maybe paving driveway approaches for a short distance is a good way to address that issue. And we do need to inspect the bikeways regularly for surface irregularities and recognize that we need to use different criteria than we would for motor vehicles. What might not be an issue for a 4-wheeled motor vehicle could be a significant safety issue or problem for a 2-wheeled bicycle. And a key thing is too, as it says in the last bullet, is try to prevent the edge of a surface repair from running longitudinally through a bike lane or shoulder. Those joints, longitudinal joints or seams, can really adversely affect bicycle control. So we need to be alert to that type of feature. Make sure drains are kept in operating condition. After a project is completed, try maybe sweep the area after that project, and think about a pavement preservation program for bikeways to try to minimize deterioration and cracking. In terms of pavement overlays, it's important to extend the overlay over the entire surface to avoid leaving that abrupt edge or seam that I talked about. And I think I'll show you an example of that. If there's any edge of pavement drop-offs that develop, try to correct those. Bring the shoulder up flush with the pavement surface. And during overlay projects, maintain the surface of inlets and grates and utility covers within a 1/4 inch of the pavement surface. As I mentioned before, pave at least say 10 feet back on low volume driveway connections, and 30 feet or to the right-of-way line on unpaved public road connections to prevent gravel and mud from spilling out into the bike area. Practice is to avoid overuse of design minimums. We don't have to use minimum widths for an entire street cross section. We talked last time, I think, about rumble strip placement, and I gave you an example of how a poorly placed rumble strip really makes the shoulder useless for bicyclists. And then not raising manholes and grates during resurfacing projects. And here's a sad example. I mean, this has had multiple resurfacing projects and the grate was not raised. So now we have a real safety issue there for bicyclists. Here's some examples. You notice the road's starting to deteriorate. Some point soon, this may be an issue for bikes, maybe not for motor vehicles, but for bicyclists. Same way here, looks like the shoulder of a roadway pretty badly. In fact, the asphalt has been removed there. Debris, I talked about sediment and debris. Notice here, it's quite a bit of sediment beyond the gutter. It's out into the travel lane. And this is, to me, is particularly problematic because notice it's an area where the bikes may be turning. So they're turning on that loose material, which really adversely affects control. Here's a driveway. Maybe this is a temporary driveway just for construction, but still it's important to pay attention to, notice you can see some larger size particles being brought out onto the roadway, also mud. So even maybe since it's temporary, even sort of a gravel or stone entrance here for maybe 10 feet or so might help at least prevent some of that mud from being carried out into the roadway. And then paying attention to the surface condition of the sort of the edge of the roadway here. And here's what I was talking about, these longitudinal joints or seams. Notice here's a resurfacing project that stopped, what, maybe 8 to 12 inches short of the underlying roadway. And now you have a real serious safety issue for bicyclists, especially due to the lack of contrast between those two surfaces. That may be difficult to see. Or here we have the joint, looks like it's not really flush between the gutter pan and the asphalt pavement. Open grates are a real problem that are not bicycle friendly. Of course, the bike tire drops in there, the bike stops suddenly, and the operator is usually pitched over the handlebars and usually lands face first or something similar to that on the pavement surface. So the injuries associated with this are really significant, and oftentimes it's not unusual that a tort claim will be filed against the agency. In northern climates, snow removal and ice control is important. So it's important to have the proper equipment and materials and personnel for maintaining the facilities. Also with bicycles, we need to pay particular attention to the surface condition related to steel. And there's many examples of that. Notice here, just in this little scene, we see a steel grate, couple steel manhole covers, more than a couple steel manhole covers. These are in areas where the bike might be turning, so we do need to be sensitive to that. Especially when wet, that steel is very slippery and can easily lead to loss of control. Open grid steel bridge decks. Some parts of the country they're widely used, but when wet, they're a real safety issue both for motor vehicles and for bicyclists. So I kind of like this design. Notice they did put in about a 4-foot wide strip of concrete here. So this is probably for all two-wheeled vehicles. So bicyclists and probably even motorcycles can travel over a surface that has a better frictional properties than the wet steel of that open grid deck. Drainage grates, I showed you an example earlier. This doesn't look very bicycle friendly. It's probably in the area where the bikes would be riding. It's around a corner, so it may be difficult to see. And then railroad grade crossings are problematic for any two-wheeled vehicle, especially bicycles. Issues are the crossing angle. If that angle is skewed, it presents some problems. The crossing surface condition could be rough or irregular, or have, if it's a timber crossing, old timber crossing, it could have bolts projecting above the surface, and then the flangeway gap opening. So let's look at some of these. I realize you may not be always able to do it, but if you can do it, notice this is a severely skewed crossing here, the way the tracks cross at an angle. But this agency was able to redesign the curb here so that, notice the bicycle is crossing the tracks roughly at right angles, which should greatly improve safety. And this looks like a pretty good crossing. I mentioned deteriorated crossings are an issue, and they are, but this looks like a fairly good concrete panel crossing. The only problem is when the railroad resurfaced the crossing, as they call it, putting in a new crossing, for some reason they did not butt these panels up against one another, and so you can see there was a gap there. And this is a recreation. This is not the actual event, but sadly during one of the, I think they call it the Cross Nebraska bicycle event a few years ago, one of the cyclists, you can see their bike tire got caught in that gap, stopped abruptly, and the rider was pitched onto the pavement and actually was fatally injured, suffered a severe spinal cord injury, and was killed in the incident. So even little details like that on a facility used by bikes, we need to be aware of that and kind of sensitive to that. And then I mentioned the flangeway gap opening, which is the opening right here and here. And these are an issue for, well, probably not for automobiles and trucks, standard automobiles and trucks, but for bicyclists, pedestrians, people in wheelchairs, people with walkers, the flangeway gap opening can be a serious safety issue. There can be if the tracks are angled, this opening can catch a bike tire and cause the bike to go out of control. With a wheelchair, the small front wheel of the wheelchair can drop into that opening. Freight railroads in the United States, of course, which most of our railroads are freight railroads, require 3 inches of opening for the steel flange of the rail wheel to pass through. And you have to have that. If we didn't have that opening, the train would derail. So there's a 3-inch opening, but that's big enough to catch the tire of or wheel, I should say, of a wheelchair, and the wheelchair can get stuck there. And then sadly, what happens if the person is alone or if there's no one around to assist them or come to their aid, they're stuck there, and then they can be run down by a train. Good statistics are hard to come by, but it's estimated every year in the United States, probably 5 or 6 people are killed in that very fashion that I described to you. So it is a tough problem. ProAg recognizes this as a problem, but right now I'm not aware of any good solutions to that problem. I see this sometimes in the cities where you have light rail lines running on city streets. I like this warning sign. I think sometimes warning signs maybe don't convey the kind of the nature of the hazard, but I think this one really does. And also the bicyclist even has a helmet on, so I kind of like this warning sign. Work zones lead to surface issues. Here's another kind of steel in the roadway. These are really nasty for bicyclists when they're wet. All this steel plate, when that gets wet, can be extremely slippery, especially where bikes are turning. Or in work zones, there may be changes in pavement condition, rough pavements. Or here in this resurfacing job, or what will be a resurfacing job, notice the contractor left this exposed manhole cover, which can also cause serious problems for a bicycle. So it would be good to put in a wedge of asphalt around here. I believe you can also buy maybe commercial like rubber products that create that temporary kind of wedge around the exposed utility cover. So signing is important to warn pedestrians, and then make sure we pay attention to the maintenance of the surface condition. And in addition to being safe, the pedestrian work zone must be accessible and detectable. But Mike, I think we're just about at the end, and this might be a good place to stop for the day. Or I don't know if there's any questions that have come in or comments.
Ron, no additional questions at this time. So Yeah, this is probably a good stopping point. So Ron, any final comments?
No, just thank everybody for their attention, for the questions that came in, and have a good rest of the day, and we'll see everybody tomorrow. So I'll turn it back to you, Mike.
All right, thanks Ron, and we look forward to part 4 of this series tomorrow afternoon. So thanks everyone for attending today.